cool. We are live. Good morning, good afternoon, good evening, everyone. Welcome to today's stream where we are cracking the coding interview in Rust. So this stream today is all about looking at some of the kind of interview questions you might get as a software developer, and we're going to have a play at solving some of these problems in Rust. So welcome to this session. First thing I do need to start with is this is a live stream session where we want you to be involved. We have chat turned on. We want you to ask your questions. Yeah, we're going to be asking you questions. We want you to be involved, give us your thoughts, give us your feedback, ask whatever you want, but I must insist that you adhere to our code of conduct. We're going to get this dropped in the chat, but basically, don't be a jerk, be kind, and any questions you ask, any comments you make, please adhere to our code of conduct. So all that stuff out the way. For the eagle-eyed among you, you may notice we have a slightly different lineup than what was promised. So today I was supposed to be joined by Nell Shamral Harrington. Unfortunately, she's unable to join, but Ryan has leapt up at last minute to take over and help and support. So for those of you who know me, I'm Jim Bennett. I'm a cloud advocate at Microsoft, hang out in Redmond in Washington and do all these live streams. But Ryan, my first time having you on the stream. Welcome. Thank you for joining. And do you want to take a minute to introduce yourself and say hello to everyone?
Yeah, sure. Thanks, Jim. It's a lot of fun to be here. Hi, everybody. I'm Ryan. I'm a cloud advocate as well, but my focus is on Rust, the language in question today. A little bit about my background. I'm originally from the US, but I live in Berlin, Germany. So coming from Europe. I am on the Rust core team and a member of the Rust Foundation board as well. So those are a little bit of my Rust credentials. That doesn't mean that I'm good at Rust coding. We'll see today how well things go, but hopefully we have a little bit of fun along the way.
Awesome. Yeah, I'm kind of glad you're here because my Rust is not the best. It's not the best. It's a language I've been learning. I've been dabbling a lot with IoT. Anyone who sees my streams, I do a lot of IoT stuff, and IoT is in C++. But as we know, it's not kind of the safest language, should we say. So I've been playing a bit with Rust as a way to do IoT and trying to avoid some of those problems that you kind of get with C++, just because it's a whole class of errors you can't get. One comment in the chat from KLP. My eyes are faint for saying, good morning, just in right time. I want low code or no code. Sorry, you're going to get plenty of code today. Today is all about Rust. But as mentioned, please drop your comments in the chat. We want to hear from you. We want to hear your thoughts on everything we're doing. So let me just bring up my screen. So this session is all about looking at some of the kind of coding problems that people get when they do job interviews as software developers. So folks get this kind of LeetCode, HackerRank style problems, and they can be sometimes brain teasers, sometimes fun problems to work on. And the idea of this series, today, next week, and the week after, is we're going to just take some of these problems and we're going to try and work through them. So you get to see how, experts, I'm not sure, Ryan, whether we class ourselves as experts or not, but how experienced developers would approach these problems. And as I say, we're going to be doing it in Rust because I'm enjoying Rust. I want to learn it, and it's kind of a good excuse to do it. So you're going to see how we kind of approach the problems. You're going to see the kind of thought process we do. And then as I start writing code, Ryan's going to correct me, point out my mistakes. We kind of talk about the syntax and how it all works as we go along. But obviously, we're here to answer your questions. So we want your feedback as well. We want to learn from you. What don't you understand? What doesn't make sense to you? How can we explain it better? And all that good stuff. So, please jump in the chat. Now, the problem we're working on today, Ryan, is the number of islands problem. Have you come across this before?
I have never come across this. So I've read the prompt, and that's about it. But I'm curious to get your take on what exactly we're doing here.
Yeah. So this is kind of a well-known problem. I haven't solved it in Rust. I think years ago I once tried to solve this, but I can't remember how I did it. But the idea is if you have a map of grid cells, kind of got a drawing here, got a grid here, and some of the cells are marked as land and some of the cells are marked as sea. And what you have to do is work out how many islands there are, assuming that the grid was surrounded by water. And so in the example here, we have got a nice picture here, 1, 2, 3, 4, 5, 6 islands. And an island is defined as a continuous block of land that is connected to other blocks of land either above, below, left, or right, but not diagonally. And so here, this one here, this is 3 blocks that are connected, C around it, 3 blocks connected, C around it, and so on. Now, I have been trying to think of what would be a good real world use case for this. And I'm guessing kind of maybe image analysis or kind of some kind of data analytics. If you've got a grid of data and you want to actually, I don't know, maybe you're counting bacteria spores, for example. You've got a picture of a titration plate with bacteria spores on it, and you kind of put a grid on it and kind of count how many of these have got bacteria in them, something like that. So I can see kind of use this problem. I imagine there's probably a library somewhere that will do this all for us, but we're going to build one. Albert Grada says, "Sup." Hey Albert, welcome. Glad to have you with us today. Cool. So I think it's the first thing we should do is, what do we need to think about? We need to think about creating our new Rust program. We need to build out some unit tests, because we need to prove that our code works. So we need to have some unit tests for it. And I've actually got an Excel spreadsheet here with some examples. 6 islands, 3 islands, no islands, 1 island, 1 island. So a few good examples. So we need to build up some unit tests for this, and then we need to write the code to do it. A question from Ben says, "Hi, is there a repo to get the starter code? I joined a bit late." Ben, no, we are actually going to be creating this repo as we go along. So the code we write today, it's the first time Ryan and I have approached this problem. The code we write today will be going into GitHub. So in fact, do I have a repository?
Just a real quick thing, Jim.
Yep.
I love this problem, and the reason that I love it so much is it's so easy to do as a human and kind of hard to do as a computer. And I love problems like that, where like humans are like, yeah, there's 6 islands there, of course, or it's obvious. But a computer is kind of like, I don't know, and it's actually a little bit of a challenge to figure out exactly how to get the computer to figure it out. I like that.
Yeah, it's true, because I mean, as humans, we have a lot of pattern recognition. That's kind of how our eyes work, doesn't it? We recognize patterns. And so to us, we're used to seeing things and just go, yeah, I can count those. I can distinguish between the green and the blue. But yeah, for a computer, it is a challenging problem. Yeah. So sorry, Ben, I will be putting I'll send the repo out once I've once we finish this, I'll send the repo out. I'll definitely be sharing it next week. So we're doing this over the next few weeks as well, doing different problems. So if it's not up in time for today, I'll share it next week. And Chidvi says, "Can you please explain the problem? Because I joined a bit late." Yeah, of course. So the problem is, given a grid of cells that are marked either land or sea, how many islands are there? So here's a grid here, 6 by 12 grid. We've got green for the land, blue for the sea. And we've marked here, as Ryan was saying, it's very easy for humans to do this, very hard for computers, which is we've got 1, 2, 3, 4, 5, 6 islands. So that's what we're going to try and do. So let's dive right in with this. So I guess the first thing to do is we need to create a Rust project, don't we? And Rust, there isn't like a Rust command line, is it? It's cargo.
Yeah.
Now, Ryan, you're on the Rust Foundation. Why is there not a Rust command line? Why do we have to use cargo? What's the history for that?
So there is Rust C, which is the Rust compiler, and that takes Rust code and turns it into, an in binary. But cargo, I don't exactly know why it was called cargo versus, Rust build or something like that, but it was called cargo. And it is the build tool for Rust and package manager and test runner and things like that. So Rust C is the compiler for taking code and producing a binary, and cargo basically orchestrates all of that and does stuff on top of it, like run tests, like download dependencies and build them, things like that.
So I guess because cargo, it's like you package up cargo, don't you? So if we think about a package, if this is a package manager, cargo makes sense as a package manager. So I guess it then adds all the other features on.
Exactly. Yeah. And In fact, the packages in Rust are called crates. So you use cargo to create crates of code.
So the naming all kind of does kind of make sense. Does kind of make sense.
Yeah.
Nice. So Chidvi says, awesome. Thanks for reading the chat. Appreciate it. No worries. We want you to be engaged in the chat. We're going to be asking you questions. You can ask us questions. So please jump in the chat. And then Chidvi also says, let's get coding. So yes, let's do it. We want to bust in with unit tests. Would it be best to build an app or a library? Do you think, Ryan, here?
I would imagine it doesn't really matter, but maybe for ease, doing an app like a binary would be easier. We could easily switch them back and forth between the two. It's really not that hard to do. So
okay, so I go, it's cargo new, and then I do
the name of the package, yeah. Or if you can do cargo init, I believe, if you want to put it into the same directory that you already have. It's up to you.
Okay, well, let's do a new folder. Just kind of show the kind of the basics. So this will go from create the code, and I've got, so it's create this number of items folder here, and I've got a source folder and a cargo.toml. Now the cargo.toml, this is the file that kind of defines everything that we want about our code, about our binary. Yeah. So what is the name that gets built, version numbers, and then the dependencies. This is for package management. So if you want to bring in packages, that goes in the dependencies file. So this is if you've done .NET development, you can kind of think of this a bit like the CS proj file or FS proj file. This is kind of this is the setup for everything that we want. And then our source code lives in the source folder. So we get main.rs, which is where everything lives. Now, actually, where I created a different folder, the Rust analyzer is not going to pick it up. So what I might do, actually, I might actually undo what I just did. And then I might just do a cargo init. Cargo init does the same as cargo new, but it does it in the current folder, doesn't it?
Yeah.
So I get the same thing. I get the TOML file, but it's in the current folder. That might be slightly nicer. Okay, so we got this created. So Ben says link didn't work in Firefox. I think this is where it should take us. Okay. Sorry, Ben, which link is not working in Firefox? We posted some resources in the chat. I think there's 3 links in there. So yeah, Katie, can you just repost the 3 links separately if Ben's having problem accessing them? And Chidvi asked, is this going to be accessible after the stream ends? Yes, on the Microsoft Reactor YouTube channel. We'll get a link posted in the chat for that as well, so you can watch it later. Cyril asked the same question. Are we able to watch it later? I mean, rewatching 10 times at least. I bet it'd be super interesting. Yes, so on the Microsoft Reactor YouTube channel, youtube.com/@MicrosoftReactor. It's all there. Yeah, so we've just put a link to that in the chat. To our YouTube channel. And yeah, so Ben says yes, there's 3 links come as 1 link. So yeah, we'll get all 3 resource links published separately in the chat. Cool. Okay, so diving into this then. One thing I am a bit hazy on with Rust is unit testing. So Ryan, how do I create a unit test?
Well, there's several places that you can put it, but actually, unlike a lot of other languages, Rust, oftentimes you put unit tests directly in the same file with other code. So this main.rs file, you can put your unit tests there. And what we normally do for that is create a separate module. So in Rust code is composed of different modules. We have a separate module called tests usually, and that test module will have the various unit tests inside of it. And so if you want to go ahead and create a module, you use the keyword mod, M-O-D, and then give it the name tests, and then curly braces there, and that's a new module for you called tests. And then in order to create one test, you create a function, and you can call it anything that you want to, so fn whatever, some test. And then you have to mark it as a test by above that putting like a hashtag, and then the brackets and test. And that lets the test runner know this is just called an attribute in Rust. There are various attributes, and one of them is test. So now the test runner will know, okay, this is the test, I'll run it as a test. And there's one final thing that people normally do, which is above the tests mod, they put a CFG modifier there. That's a command, like a command flag that basically, if you do CFG and then parentheses test, then that lets the compiler know only compile this when I'm running tests. Otherwise, when you're building your binary to actually run it, you know, if you're going to run your binary, it won't even compile the test code. It will just ignore it completely. So this is, if you have a lot of tests, you don't have to worry about it bloating your, you know, binary size or something like that.
Nice. That's pretty cool, because in other languages, you'd have like a separate project with your test code in it, wouldn't you? Whereas having this in there is kind of quite cool. And the fact you just say compiler flag just cuts it out, gets to that code bloat. Nice. So in theory, then I could go. Is it cargo test?
Yes.
That run the test, and that should, I guess, pass, because we don't do anything.
Exactly.
But if I do, like an
assert false. So assert with an exclamation, or sorry, assert exclamation point, and then just put false in there. And this will fail. And so if you run it, you'll get a test failure.
Yeah, test fail.
Yeah.
Cool. So we've got our first test in here. Let's think about how we can get our code, our island modeled as a test. So what I did do earlier on to make things easier is I went through my examples here, and I've created a list of trues and falses. True for land, false for C. I don't know whether this is the best way to model it, but it felt like kind of a good thing to do at the time. So is there a two-dimensional array that I should use for putting this in? Because I was reading somewhere that two-dimensional arrays are not ideal in Rust. So what would be a good way to model this grid of data?
Yeah, that's a good question. I mean, there's multiple ways we could model it. We could have a two-dimensional array, an array of arrays. That's fine. We could have one array, and we just know what, you know, how many elements represent a row or something like that. There's also, it should mention that there's a difference between arrays and vectors in Rust. Arrays are collections that are known, the size of which is known at compile time. So if we know how many elements there are, we use an array. Whereas if we're not sure how many elements there are and it might change during runtime, we would use a vector. But in this case, we know how many elements there are and it shouldn't change during runtime. So an array is a fine thing to use. So I'm not sure. I think I maybe would think about doing a single array and just knowing how many elements are in a row.
Now you say we know how many elements are in there. If we're passing, so if we write a test with this, we're going to have to pass this array into a number of islands function.
Yeah.
And that function is going to have different numbers of elements passed into it. So when we pass in this one, it's going to have was this 6 by 12. When we pass in this one, it's 2 by 4.
Very good.
So can we define an array as a fixed size and then pass that in as I don't know how big this array is? Or do we always have to fix the size of the array as a parameter?
So the fun answer is yes, you can. So Rust has generics, and one thing that it can be generic over is the size of a fixed size array, which is kind of mind-bending. But I think that that's a little bit of an advanced feature. And since we want to start simple, probably we would start with vector instead. And vectors can be of any size, and we don't have to specify that size at any point.
Okay, so if we do it as like a one-dimensional vector, then you're saying like this, that could define our island. Okay. Yeah. So a couple of things in the chat. Corey says, "Hi, Ryan and Jim. In Rust, we trust." Hey, welcome, Corey. So Corey is my colleague in Europe, in Stockholm. Awesome to have you on board. Corey's done some great videos on Rust as well. One of the links we've put in the chat is Corey's series, Getting Started with Rust. So if you want to learn some of the fundamental basics, check out Corey's series. Link is in the chat. And meet.the requirements say a vector is an array list for JavaScript developers. Yeah, so a vector it's basically a collection for putting things in, kind of a one-dimensional collection for putting things in, and you can add more things and and take things off. So yeah, an array list for JavaScript developers. I don't know JavaScript, so I'm assuming you're correct. But yeah, it's a vector. You get similar kind of containers, various lists and all that in multiple different languages. So it's basically a list. So we take our test one here and we define a vector. So we say let islands equal, and there's like it's vec bang, isn't it? That's the syntax for defining a vector.
Yep.
And then we need to pass in. How do we pass it in? Can I just do it in parentheses?
You can do it in parentheses, although it's more idiomatic to do it as square brackets, like that.
So I would, if I just put this in here, so basically it's like this.
Mm-hmm.
And that's got, so this is our grid here. We've got the truths for the land. Okay, so this is our islands. And then we need to pass this into our function to do something. So there's, with the unit tests, there's some kind of assert equal. Is it EQ or equal?
EQ, yep.
And so this would be the result of our number of islands. I'm just going to type a function randomly that doesn't exist. I can't spell today. And that's supposed to have, we said 6 in this one, didn't we?
Yes.
This is kind of our unit test. We define the island, we're going to call our function, which we haven't built yet, and then we're going to pass in the islands, and then we're going to assert this equal to 6. So if I just define this function here, this takes a, now this it's I cannot spell today. Islands, but this is a vec, isn't it? It's not, so the vec, lowercase vec with the bang, the exclamation mark, that's like a shorthand syntax for creating a vector.
Yeah, it's called a macro, exactly. Yeah, and it allows you to create a vector, because normally how you would create a vector without that macro is to create the vector and then push each element onto it manually. But instead of doing that, Rust provides a vector that does all of that for you. So that's essentially generating the code that you would otherwise have to write.
So this is kind of the equivalent of let mutable or mute islands equal vec new, and then insert. It just packages that code up nicely for you. So
exactly.
Okay, so this is kind of like the templates you get in C++, and that the macros, this will actually expand in the compiler into a block of code. Probably highly optimized as well, I imagine. Cool. So the actual type of this then, this isn't, so we can't just pass in, we can't say islands as a vec bang, because obviously you say that's a macro. So the actual underlying type is a vec.
A vec, but you have to say a vec of what?
And this is, it's a vec of bool, isn't it?
Exactly, yeah.
Now the Rust analyzer should be running. I don't know why it's failing to discover the workspace, because the Rust, so if you're using Visual Studio Code for Rust, I will say this, there is a Rust analyzer, which is, you don't want the Rust one that's been deprecated, you want the Rust analyzer extension, which for some reason is not being very happy with me today, but this will actually put the types in. So where I've got, let islands equal, we don't know what type this is. We're not explicitly saying what type this is, but the Rust analyzer would normally fill this in and actually just add a little bit extra. It doesn't change your code, but it adds some text inline to show you what the type is. And yeah, I don't know why the Rust analyzer is not working for me today.
I wonder if the cargo init maybe it messed it up somehow or something like that. But yeah, that's a shame, because it is very useful to have those IDE features happening. Yeah, maybe disabling and reloading could help. Don't know.
Right, let's just reload this. Let's just reload. And then I'm hoping when I reload, you won't get kicked out of the live share session. And then okay. Let's see if, oh, that's looking better, isn't it? Are you still in the live share session?
I did get kicked out, but I think, oh no, you have to resend a link to me.
Okay. Make sure I put it in the right chat, not in the public chat. Don't want everyone else joining in my live share session. Cool. Okay.
All right.
There we go. So Sayak says, would it be possible to demo the array size generic syntax? Yeah, do you want to, could you quickly, Ryan, just quickly write what the syntax would be for generic array?
We could do something like this. I'm up at the top. Yeah. Islands. And essentially you would do bool n like this, and you have to say that n is a generic number like this. So essentially what this is saying is I have an array of bools and it's of some size n, and the caller of this function will tell me what size n it is.
So I would call that by saying num of islands, and then in the pointy brackets I would put
5
or whatever, and then it would expect an array of size 5.
Yeah, exactly.
Cool. Okay, so it's like that's how you do it. That's pretty cool. It's pretty cool stuff. Okay, so our Rust analyzer is now working now that we've reloaded, and you'll see we've got the islands is a vec of bool. So it's this text isn't there. If I actually press the sideways arrow, I kind of jump straight past it. So it's just kind of extra on-screen sugar, but it shows me what the type is. So Rust has type inference. Rust will work out what the type is. You don't have to explicitly say that islands is a vec of bool. It'll work it out for you, and then the Rust analyzer fills it in, which is quite nice. So that we can see that vec of bool, and we can see that we can then put that in here. Now it's saying num of islands.
Yep. So
found.
Number of islands is not found because we're in the test module, and num of islands is defined in the parent module. So we have to bring num of islands into scope inside of our test module. And we do that by doing use. So I think even Rust Analyzer is saying, you can prepend crate : to it. That's another way to use this sort of fully qualified, or you can import num islands into our test module there as well using this use syntax. And that brings it into scope and allows us to use that function.
Cool. So that's automatically added this use crate : num of islands up here. So that works. And now it's still not liking it.
Do we have to save perhaps?
I think why? Because we haven't specified the type of num of islands, because num of islands actually returns a size, isn't it? So we'll do 0 for now. But yeah, this function is designed to return a size, and I hadn't actually specified that. So it was saying assert that equal this returns nothing, and nothing can ever equal 6. So that was why. So Bob MCN says, if this was really a coding interview, would you spend this much time on tests? Isn't the interviewer more interested in how you solve the problem? So if you did this on a platform like LeetCode or HackerRank or all that, then the test would be built automatically. So you'd have that, and they would tell you that when you run this code, we would pass in the data in this format, and then you would then write the code to do it. So you'd have those tests built automatically if you're using those platforms. Otherwise, it all depends on the kind of coding interview. If somebody asked me in a coding interview to write a function to do something, I would probably start with tests, because if I'm building code for production use, I want to have tests for my code. And the advantage of having tests is I can prove my code works. I can demonstrate that it works. I can test what I'm doing is actually going to pass or fail. If I didn't write the tests, how would I know whether my algorithm actually works or not? I need some kind of proof. So yes, in a coding interview, if you're using an online tool, the test will be built for you. If you're not, it's very important to actually have this here, because the first question going to be asked is, does it work? And I need some kind of test to prove that it works. And once I've worked out my test syntax, because I've got all my examples here, I can then just bang and create more tests with it. So that's kind of why we're spending a little bit of time talking about that. But great question. We can never have too many tests. You can, but in general, lots of tests is good. Meet requirement says, what's usize again? So usize is an unsigned integer that's based off the size of the target you're building for. So on a 32-bit machine, it's a 32-bit one. On a 64-bit machine, it's a 64-bit one. Why am I returning usize rather than int 32? That's a great question. Yeah, so I mean, Ryan, when would you use usize?
Well, I mean, the first question is, do you use a signed integer or an unsigned integer? And I think here, when we're talking about numbers of things, like we're never going to have negative number of islands, right? So having an unsized integer of some type is the right way to go. But there is U8, U32, U16, U128, U64. There's a whole bunch of different unsized integers. So why would we use usize? Usize is often used to index into arrays and things like that. It's generally kind of a catch-all for when you are not quite sure if you need a certain size, pick usize. I think it's just a good default, really. But we could do, we're probably going to like hold a count in something like that, and it's often done in these sized integers. So there's not really a good answer here, I guess, is what I'm saying.
I guess it's probably the most optimal for the programming architecture, isn't it? Because that can be going to live in like a register. Then it makes sense if you've got a 64-bit machine that you want to have a 64-bit number in your register. Maybe. Don't know how much of an impact it'd have here.
Probably none at all. But but yeah. I mean, maybe that might be a good reason to say.
Cool. Cyril says, maybe a silly question, but how do we account for the grid with a vector of balls such as this? Don't we lose the ability to know which line we're currently on? I mean, yes. So we'd need to write some code to convert the columns and rows to positions. But why would we do a one-dimensional vector rather than a two-dimensional vector?
I mean, we don't have to. We could do a multi-dimensional vector. Then we have to have this vec be also, it would have vecs inside of it. So for each line from 19 down to 30, we would do vec bang and that again, and that would work fine. We'd have to make sure that each line is of the same size. So we could, we don't want to allow programmers, for instance, to pass in a vector where the lines are of different sizes, right? That wouldn't really make any sense. Or maybe it would. I don't know. We'd have to decide how to handle that. So, this is really just a question of how would you do it in any language, right? Any language that has collections, we can certainly do it multi-dimensional or one-dimensional.
Yeah, cool. Question from Santiago about this then. I guess we're going to use a @ball ends on array instead of a vec because you know the value to allocate. That's going to impact more in compilation. So yeah, if we use an array, we have to know how big it is, unless we use the generic array size syntax. Because we've got multiple test cases of different sizes, then we don't know how big it's going to be. So what gets passed into our number of islands function is going to vary in terms of size. So we can't say we're always going to have a array of whatever we've got here, 72 booleans. We're going to have sometimes 72, sometimes 8, sometimes 1, depending on the number of islands. So yeah, that's why we're not using the array. Walls Matthew says, doesn't usize have to do with memory addressing and pointers? Unsafe. So it's not unsafe. It's definitely not unsafe. But yes, it's based off the architecture of your machine. So if you have a 32-bit machine, a usize is a 32-bit unsigned integer. If you have a 64-bit machine, it's a 64-bit unsigned integer. If you have a 128-bit machine, then you're about one of only 4 people on the planet. Yeah. But yes, it's kind of related to the size of the architecture of your machine. So actually, going back to the question about the one-dimensional array, I guess what we also need to do is we need to have actually the number of columns and rows, so we know how to slice up our array, don't we? We've got 1, 2, 3, 4, 5, 6 columns, and I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rows. So we need to kind of know both those, don't we? So we can kind of slice it up. Otherwise, we're not going to go, is this 6 by 12? Is it 12 by 6? Is it 24 by 3? So we kind of need that. Panchkav says usize equal unsigned integer of size inherited from computer architecture. Yes. Yeah. So if your architecture is 32 bits, it's a 32-bit number, 64-bit, 64-bit number.
Yeah, and we should point out, like, the reason that we have this in Rust is because Rust is, at the end of the day, a systems programming language. So for our program here, what size architecture we're running on is not really of consequence, right? But for a lot of programs, systems programs, it is. You want to be able to control the exact size of integers that you're passing around. So Rust kind of forces you to make some of those decisions. But that's just what you get when you use a language like Rust.
And I guess you could compile it for 32-bit, you could compile it for 64-bit, couldn't you? Actually, compile different binaries to run on the different platforms.
Exactly. Yeah.
Cool. Okay, so we're kind of more than halfway through, and all we've done is written a test case so far. So let's think about how we're going to do this. So, as you said, as a human, this is easy. I've got some thoughts on how we could work this out. Ryan, have you got any thoughts on how we could do this?
To be perfectly honest, I have some thoughts, but I don't know if they're good ones.
Okay, so what are your thoughts? What are your thoughts?
I mean, the first thing I guess the naive approach, right, would be to iterate through the entire, every single cell, and then maybe ask some questions about, is this on an island that I've seen before, and have some sort of collection of, start and then try and figure out where the edges of the current island that you're on. And once you figure out all the edges, remove them from the list of possibilities and move on. I don't know, though. I don't know exactly what the best way to go about this is.
Okay, I mean, that sounds like a viable way of doing it. So we would have some kind of thing to track the cells we visited, and then we'd go cell by cell. So we'd start here and say, I'm on island. Yes. And if I am, we can look up, down, left, and right to see whether they're still islands. And we kind of use this to almost like depth first. We kind of visit every single cell that we're connected to that is green, and then mark those as we visited them. And then once we kind of hit C, we count that as an island. So here we'd start here. Yep, this is an island. We'd go here, it's an island. Here is an island. Mark here is not. Mark these as visited. And then we'd carry on chugging through. So next time we come round, we would ignore that one. We'd ignore that one because we've already visited them. Is that kind of what you're seeing?
Yeah, I think so. I don't know. Is that the best way?
It's a way.
It's a way. Yeah.
I mean, let's try it. Also, meet the requirement says if your function is designed for web, do you still return usize? I guess if you're building an API, you'd want to be very specific on the data type you're returning, wouldn't you? So you would, if you know that you'll need to return a 64-bit integer, you would return a 64-bit integer.
Yeah.
Because you don't want to find that you deploy your API to two different machines and you get a different response coming back from each one. You want to make sure you want to have consistency for your API no matter what platform it's running on. So no, I would say you wouldn't return usize. Don't mean to hold up as I'm just wrapping my head around all the use case data types. No, it's kind of why we're here. It's not necessarily about solving the coding problem. It's about the journey and the discussion and kind of learning about all this. So yeah, no, it's great. Keep asking the questions. That's kind of why we're here. Benjamin says, where can I find the Excel file containing the testing data? It will be on GitHub eventually. Join us same time next week, and I'll definitely publish the GitHub repo. But it's not ready yet because we're writing the code that's going to go in there. So it'll all be on my GitHub. GitHub.com/JimBobBennett is mine. You will see it there in my public repos probably later on today, and I'll definitely share the link next week. Okay, so we're going to iterate through the list. So I should leave it returning 0 for now. So we're going to, I guess we need a for loop, don't we? For col in 0 ... cols. So we kind of go across the columns, and then we go down the rows, don't we?
That's one way we could do it. Yeah. Yeah.
I don't know if this is the most effective way. Let's go rows first, then columns.
I guess just as a heads up, this is not how I would write it, but I think it's important to go through how you would write it, and then we can talk about how maybe a more idiomatic approach would be. Or if you wanna have me stop you short right now.
Okay, yeah, why not? Show me how you'd write that. What's the more idiomatic way?
Well, I think probably what you're going to do is directly index into islands, right? So that you'd say like islands and then square brackets, and then figure out what the index is for a given row and column, right?
Yep.
And direct indexing in Rust is certainly possible. You can absolutely do that. But potentially a more idiomatic way to do it would be to use an iterator instead, which gives you access to, which allows you to sort of iterate through and get access to each element in turn that you want to. Okay. So how are we trying to iterate? Do we want to like, I guess we're going to go around and find a cell and then look at its neighbors, right? Is that what we're doing? Okay. Yes. In that case, I guess we do need to be able to direct index, because we're going to be jumping around in the collection kind of randomly, right?
Yeah, because if we're here, for example, this cell here, we need to go up, down, left, and right, don't we?
Yeah, that's true. Yeah, then in that case, forget what I said. Let's stick with direct indexing then.
Yeah. Okay. So I guess the first thing we need is some kind of function that will get and we'll get from the row and a column, actually get the index and the vector. So we need to know for that, we need to know the row we've got, we need to know the column we've got, and then I guess we need to know the actual number of columns. That we need. Because if we're saying we're on column 1, 2, 3, 4, row 1, sorry, 0, 1, 2, 3, row 1, we need to know that we're actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be the rows minus 1 times the number of columns to get all the cells in the rows above us, plus the actual column. That makes sense.
Yeah, by calls, do you mean like the size of the size of a row, right? How many cells are in a row, right? Okay.
Yeah. Yeah. So it would be so the cells above would be row minus. But it wouldn't even be row minus 1, would it? It would just be row.
Yeah, because they're 0 indexed. Yeah.
0 index, so row times cols. So we're saying if we're in row 1, we want to have 1 set of columns because we're 0 indexed. So it's rows times columns. So the position is the cells above plus the row we're in. And then we can just return the position.
Exactly. Yeah, great.
This is kind of one of the Rust syntax things for folks who are new to Rust, is that you don't, there's not like a return keyword, is it? You don't go return this.
Yeah, you can. That does exist, and you can do early returns, for instance, but it's definitely more idiomatic to not do final position return. Yeah.
Cool. So, oh, it's not row, this should be column. It should be cell above plus column. So if we just test this in our head, if we've got row 2, column 3, row 2, column 3 would be row 0, 1, 2, column 0, 1, 2, 3 is that cell there. Row 2 would be 2 times 6 plus 3. That will give us the 0 index thingy. So 2 times 6 plus 3 is 15, and this is 0, 1, 2, 3. Yes, that would work. I think that would work. Okay, so that gives us our index. So I can say in here, let vec index equal get vec index from row col cols. This tells us where we are in the cell, and we can go let is island equal islands, and then it's just square bracket, isn't it, for the syntax? And this gives us whether we're an island or not on the cell.
Yeah.
So if we are an island, we need to look at all the cells around. But we also need to track, don't we? We need to track, have I visited this before? Cyril C saying, I guess it's a good way since we won't visit the same block twice. Yeah, so we need to kind of track what blocks we visited. So we need a way of storing this. Oh, and Ben has a question. Can you return an instance of the variable in the same line like in Ruby? So what you mean is, can I just do this? Yes. Yes, I can.
Yeah, you have to remove the final semicolon, but
yes. Yeah. So when there's a semicolon at the end, that means it's a line that needs to be executed without the semicolon. It's saying this is the return value. So Ben, yes. Yes, you can. I mean, I could even go all the way, really, couldn't I? I could just do that. Yeah, make it short. Okay, so if we're tracking where we've been to before, we need to store, I guess, the would we build up another vector of booleans to track the ones we visited, or would we kind of put the index in some kind of unique set? What would be the idiomatic Rust way?
I don't know if there's necessarily an idiomatic way, but it seems like maybe putting it inside of some kind of set. I mean, we can put it back into another vector, for instance, and keep track there. I guess we have two pieces of information, though, like the index of the cell and whether it's been visited or not, right? Mm-hmm.
Because we could just put the index inside some kind of set, so that, and then that's just a quick lookup of if it's in the set, I've visited it.
Yeah.
So that gives me a very quick lookup to quickly check, is it in the set?
Yeah. Yeah. Then we can use a hash set then.
Okay. So actually, if we start by declaring a hash set, then is it literally hash set?
Mm-hmm. Yep.
And it'd be hash set new, isn't it?
And you'll notice at the very top of the file, Rust Analyzer has already brought hash set into scope for you automatically.
It's nice and helpful, isn't it? It's
yeah.
good, that. Now I've got a red squiggle here. Because I guess I need to say what is in it. It's a hash set of usize, isn't it? This is generic, so I need to specify there's something in there.
Yeah, and the syntax for that is it's actually called the turbofish syntax. So you have to do hash set colon so hash set colon then that the syntax you had before, the brackets and usize, and then colon again. And you'll notice that this usize thing kind of makes it look like a little bit of a fish with a tail at the end. That's turbofish syntax.
Okay, that's cool. I like that. Turbofish syntax. Yay! Yeah. But that's the syntax for creating it, but the actual syntax for declaring the type is just the bracket straight after it, isn't it?
Yeah. It's arguably one of the ugliest parts of Rust syntax is the turbofish, but at least it has a cool name. So.
Yes. If you've got to be ugly, you want to have a cool name, don't you?
Yeah.
Wald Matthias says, I wonder if it makes sense to do a first pass over the entire matrix, simply recording true values and assemble islands for these locations. Yeah, that could probably work. If you know all the different bits together, if you know which ones are islands, you could just say, am I connected to another one? And if I am, kind of tick them off that way. Yep, that might work. Mustafa says, we'll end up adding all nodes, so much more efficient to construct another vec. We needlessly will calc hashes for all cells for hash node. I don't know. I guess it'd be interesting to do a performance test on this at some point as to whether just putting into a vector is faster than calculating the hashes each time. I imagine for small maps, it would be, but if you had a 1,000 by 1,000 map, it might not be. But yeah, I guess for performance, if we wanted to think about performance, yeah, that could be an interesting optimization to investigate, or maybe even have it. So depending on the size of the island, it flips depending on what's the most efficient. Yeah, good observation though. I think for what we're doing, I don't think it's going to be too much of a performance issue. Yeah, cool. So if we're an island, we want to. So is it visited.insert?
Mm-hmm. And
then we add the vec index. In fact, we want to say not just if it's an island. If we've actually visited, we need to drop out. So, and not visited.contains vec index. Because if we've been here already, then we don't want to actually check it. Now, this is saying I have to borrow vec index. So this is the one of the interesting things about Rust, isn't it? Is ownership. So whenever you do something with something, you have to own it. Otherwise, you can't do it. So when we pass this to the vector, because not the hash set, because it now lives in the hash set, we have to explicitly say we're going to give over access.
Yeah, I mean, this contains on hash set is a generic function that works for any kind of hash set, no matter what the value of the hash set is. And so for numbers, this isn't really of consequence, like our vec index. But you don't want to have to pass ownership of the thing you're testing for over to the contains method in order to just see if it's inside of the hash set or not. So you let the contains method borrow the value that you're testing for, because all it needs is just to take a peek at it. It doesn't need full ownership over it. So that's why we have an ampersand there.
Yeah. So all the while we're inside this contains function, it kind of owns it, but when we leave the contains function, it gives it back. Mm-hmm. Essentially, yeah. And then we've got this error here because we're not mutable, aren't we? So with Rust, everything is immutable. You can't change it. So we just mark the hash set as mutable so we can insert things into it, don't we? Which is because we didn't have to do that for our tester. We didn't mark our vector as mutable because we're initializing it with all the data. We're not actually changing it afterwards. So inside inside this vec bang, it'll do some kind of mutability inside there to build it. But once it gives us back to us, it's immutable. So we don't have to declare this one. But because we're putting stuff on a hash set, we have to declare it as mutable.
Yeah.
Cool. Yeah, Grinspliz asked me to scale up the editor. Yep, scaled up. Hope that let me know if you need more. And Shamel says, welcome from Iraq. Welcome. Glad to have you with us. Okay, so we've marked where we visited. And then we need to check kind of above, below, left, and right, don't we? To see whether they are. So you know what? I wonder. I just want to check whether it is land in a particular row and column. So we need all that. We need just think about kind of factoring this out into a function somewhere to see what we're doing. Maybe actually we want the hash set as well in there, don't we? So I wonder if we can kind of put this here. So what I'm thinking is this needs to be a mute. So I think if I put this in a function, because we can then call this same function for above, below, left, and right. So it kind of becomes like a recursive thing. But I need to pass this hash set in It needs to be mutable. So what's the syntax for? It's something like that, isn't it?
Yeah, you want to pass in a mutable reference to it so that you don't pass ownership of it. Otherwise, if you did that on the first iteration, you pass ownership, and after check is island is done, it would deallocate the hash set. And of course, Rust wouldn't allow you to do that. It would give you a compiler error beforehand, but your code wouldn't compile. So passing in these references allows the data to continue to live after you've called this function. But you still have some reference to it. You can read from it or you can mutate it.
Yeah. Okay. Yeah. So we're saying, yeah, we're passing it in. We're saying, here's a reference to it. You can use it for just for the time you've got it. We'll take it back afterwards, and it is mutable, so you can change it. But if we knew it wasn't going to change in here, we could actually just pass in, even though it's mutable on the calling function, we could pass it in as immutable, couldn't we? If we knew someone wasn't going to modify it.
Exactly. Yeah.
Okay. So we're saying, we get the index. If it's an island, and we haven't visited it, we'll visit it. But then we also need to run the same thing for the cells above, below, left, and right, don't we, to check for that? So we can say, so if our column is greater than 0, because we don't want to check outside the bounds, do we? If we're here, we don't want to check here because there's nothing there.
Yeah.
So if our column is greater than 0, we can then recurse through what we're doing, but we pass in column -1, so we go back to the left. You can also then say, if the column is less than the number of columns that we've got, we can add 1. Now, if we've got 12 columns, 6 columns, sorry, 1, 2, 3, 4, 5, 6. If we are 0, 1, 2, 3, or 4, we can do it. So we need to be, if we're less than columns -2, isn't it? Because we're 0 indexed.
Yeah.
Yeah. And then we kind of repeat the same kind of thing, but with the rows, don't we? So if row is greater than 0, we want row -1.
Is it calls -2 or is it calls -1? Because we're doing a less than check, not a less than equals to.
Yes. It is. Good spot. So the same for row. For this, we need to know the number of rows, don't we? So that's actually missing from our function. So let's add rows usize to that. We've got that here, haven't we? So, we need to pass in the rows everywhere. So we know how many rows, how many columns, we're passing it all in, and we're checking the. So we're going through and marking each one as visited. So I guess the one thing we are missing actually is just the actual count.
Yeah.
We declare this as mutable. This makes a usize so we're all consisting.
Yeah, I guess the problem is that you might check neighbors, but then those neighbors also might have neighbors that are part of the same island. So we can't. We have to figure out like where the edges of the island are.
So I mean, if we just say if this just returns a Boolean, we can say, oh, this is where we need to use a return syntax if we drop out, don't we? So we can say, if this is an island, if this is land, we will count it as, yes, this is land. And we're going through and all we're doing is just marking off everything else. We only really care once we kind of roll up the stack. We just care to say, yes, we found an island. And we count that. So we can say, if check is land, count of islands. I do plus equals in Rust.
Yep.
And then I return count of islands. Old Matthew says, I have this feeling if we factored this using enumerate, maps would be shorter or more idiomatic. And those, if maybe, the screaming user match. Yeah, probably. Because I'm very much a beginner. So I'm doing this thing how I would do it. And I'm glad Ryan's here to kind of help me and adjust me. And certainly over the next couple of episodes of the series, Ryan or Nell will be getting me to be more idiomatic, which is nice. So you know what? Should we just try it? See if we've got it working.
Let's do it.
Okay.
Oh, we got a failure. Scroll on up. Oh, in the terminal.
Terminal.
Assertion failed.
Okay.
So
what do we get wrong?
One thing you can do in assert equals is also print out a message as well. Although
if I do that and then assert equals, can I just print?
Yeah, print line.
And then I could just do that. Is that the right syntax?
Yeah, that won't print the number on with a new line afterwards. You want print ln if you want to have a new line at the end.
So if I run this, scroll up, it's not, where does it? It doesn't actually print. How do I get it to print?
Oh, the reason for it is because you're panicking beforehand. If you look, there's a panic message there saying panicked at attempt to subtract with overflow.
Ooh.
On line 23. So one of our checks must be incorrect.
So if the column is less than column -1, ooh, so the number of cols is okay. So number of cols is wrong then. Row, col, cols, rows. Row, col, cols. Oh, there we go. I was passing in the wrong thing.
Whoops.
I was passing in the column number rather than number of columns, and bang, fixed that, and it works.
Wow.
Test passed. Woohoo!
Amazing.
So in theory then, if I take this test and I copy and paste this, I know we're kind of at time, but let's just do one more. Ooh. We call this one test 2, and let's take this more complicated one here. Just drop this in. Islands. We have 6 islands here, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 12 by 20. So columns 12, and this also has 6 islands in it. Run this.
Wow.
We pass. We did it.
I'm I'm not shocked because I knew you were a very smart person, but boy, wow, I'm very impressed. That's awesome.
Cool. So a couple of questions in. Oh, I think we got to all the questions. Yeah, so we did it. We managed to actually pass the coding challenge. We've now got a job as a junior developer. Excellent. Cool. No, this has been a lot of fun. So yeah, going to wrap up there because we're kind of at time. Thank you everyone for joining. We've put a lot of links in the chat. We are running what's called a Cloud Skills Challenge with this. So one of the links we put in the chat is for a Cloud Skills Challenge. So this is your chance to actually update your skills on Rust, learn a bit of Rust, and get a little digital badge to say you've done it. A few people joined this challenge already, but essentially you work through our Take Your First Steps with Rust learning path. It's about 5 hours of learning with a whole of modules covering what is Rust, getting set up, creating your first Rust programming, if else, loops, errors, memory management, generics, modules, testing, a whole lot of good stuff in here. So work through this and see how far you can get through it. There's 16 other people who are working through that at the moment. It's kind of a great way for you to build up your skills. So yeah, join with that. And otherwise, thank you much for joining. I'll be back next week. Hopefully Nell will be better and better to join us. If not, I might be leaning on Ryan again at the last minute. So I hope you enjoyed this. We're dropping a survey link in the chat. We do appreciate your feedback on everything we do. We want to make sure the streams are right for you. So we'll get a survey link in the chat. Please fill that out. Let us know what you liked, what you didn't like. And then we can kind of make sure we do the best streams for you. But otherwise, thank you very much indeed for joining us. Enjoy the rest of your day wherever you are in the world.
Thank you very much.